Here is 94A from chapter 4. This is a redox reaction in basic solution. So remember, that means you're going to have not H plus ions in excess, but OH negatives floating around in solution because it is in basic solution. If you look here, you have chromium and everything, which is a little bit strange. Same element could be oxidized and reduced, which is probably the case here more than likely. So here's some solid chromium. It says solid in the book, so that is a 0 charge. Right here, oxygen is -2 times 4 is -8. That means this chromium, since this is a -2 overall, has to be a +6. So our chromium here is a +6. And over here, you can do this a couple different ways. You can do OH elements individually, or you can say, okay, this polyatomic ion OH is a -1, and there's 3 of them, so it's a total of -3. That means this chromium is a +3. So you have chromium, some chromium atoms going from a 0 charge up to a +3, and some going down from a +6 to a +3. So chromium is being both oxidized and reduced. I'm going to do reduction first. Doesn't matter which one you do first. So you have this chromium, I know, is being reduced, CrO4 -2. It's going down in charge to CrOH3. It's going from a +6 to a +3. Reduction is gaining. That means this chromium is gaining 3 electrons. So plus 3 electrons. Now we need to, you can do your hydrogens or your oxygens, or we can try and get the charge, overall charge equal. So if we kind of look here, you have a charge on this side. Again, not individual atom charge, but overall charge. This is -2. -3, it's a -5. This side is 0, so to make them equal, I'd have to go plus, oops, I was going to do H plus, but we're in basic solution, so scratch that. We're going to do plus 5 OH negative to make it a -5 on both sides. Now if we put in waters, over here we have 3 hydrogens there and 5 there. We have 8 hydrogens and 8 oxygens. So we need 4 waters. It gives us our 8 hydrogens, 4 oxygens there, 4 oxygens there. There's our 8 oxygens, so oxygens are equal on both sides. Oxidation, you have your chromium with no charge going to chromium with a +3 charge as part of this compound. So that means that this has to be losing 3 electrons. So you add those to this side. And this has a -3 charge, so this side needs to have a -3, so we're going to add in 3 OH negatives, which is good because we have 3 OHs over here. Make sure electrons lost in oxidation, 3 of them, is equal to electrons gained there, so those are equal. And we'll cancel out anything else that will cancel out. So we have 3 OH negatives here being used, 5 being produced, so the net would be 2 being produced. So if we put those together, we have an overall reaction CrO4 -2 plus 4H2O plus a chromium. Forming, we have 2 of these, so 2 CrOH3 plus 2 OH negative. Charge should be equal on both sides. -2 charge, -2 charge, and all the atoms should be equal on both sides. Again, it is redox, there's a transfer of electrons, and it happens to be from one chromium to another, this chromium to this chromium.